Hello everyone. So today I'm going to be going over more about arrays in C. Now with C there's a function called size of, which takes the size of an array in bytes of memory. So it'll count however many bytes of memory an array holds, which means that it's kind of important to know first off what type of array you're using the function on and what amount of bytes that type holds per variable or per value. For example, a character such as, let's say, a capital A is equal to 1 byte. The number 1, an integer 1, however, is equal to 4 bytes on most computers, which means that there is a difference between just having an A and just having a 1 in an array. A 1 by itself, if it's an integer, will be looked at as 4 bytes of memory, and the A will be looked at as 1. Now if we did A, B, C, and D in one array, that would be looked at as 4 bytes of memory, and the integer 1 would still be looked at as 4 bytes of memory, which means that they would be equal in the size of memory that they hold. Now let's actually make a couple examples so it's a bit easier to explain. If we do character array word and we make it 5 letters and we initialize it, which you can initialize using curly braces. Inside these curly braces you would just do something like single quote W single quote to initialize a W as the first part of your cell, comma, and then the same thing for O, and we'll just finish this off with spelling words and a semicolon. Now the important thing to note is to use single quotes because that gives you the value or returns the value of the letter inside, not the pointer to it. And we'll go over a little bit about that near the end of the video about what's the difference between a single and double quote. But this right here will initialize these and tell the array word that it holds 5 values. So we have W, O, R, D, and S. And now they are in their corresponding spots. Let's also make an integer array, and we'll call it nums, and we'll also have this hold 5 values, and we'll initialize it the same way. But because these aren't letters, we can just put the numbers straight in there, so 1, 2, 3, 4, and 5. And always remember to end your lines with a semicolon, kids, because otherwise you get errors, and it's very sad. Now, let's actually use this function on one of these arrays, and we'll just assign the value that the function returns to integer I. So int I is equal to size of, and let's start off with word. Now by doing this we're assigning the number of bytes of memory that the array word holds. Now since a character type is 1 byte per value and the word array holds 5 values, we should get 5 as the size of word, and that means that I is equal to 5. So if we printf %d \n and we give it the variable I, save, if we compile and run this we should get 5 to be spat out of our little thing up here, and that's what we get, 5. So one second, let me actually make this a little bit bigger for you. Okay, there we go. So now you can kind of see it better. I hope that this is 5. Now that makes perfect sense. Now what about numbers? And this is the important part about the size of function. If we put nums in here, it will take the size of the bytes, the number of bytes the nums takes up. Now an integer takes up 4 bytes of memory per integer, and we specified 5 values for integers. So it's 5 times 4, not 5 times 1, which means that this should return 20. So if we compile and run this, we get 20. Awesome. Okay, everything's working great. It's working the way it's supposed to. Now the whole point of size of is that it returns the bytes that an array holds, or returns the amount of bytes that an array holds. How you use this is up to you. A lot of people, when they first start getting into arrays, want to try and find out how big an array is dynamically so that they can index that array and index every variable inside of it using like a for loop or a while loop. Now that's all great, but if you're not using a character array, that means you have to divide by another number so that you get the amount of values in the array and not the amount of bytes in the array. Now, an example of this is that because the array nums has 5 values, but each value is 4 bytes, if we divide by 4, 4 divided by 4 is 1. So what size of nums would return if we divided this by 4 is 5. Or, yeah, so it would return 5. Basically it looks like this. Size of would return 5 values times 4 bytes. However, because we know that an integer is 4 bytes, we know that if we divide by 4, we would get 5 times 1. So we'd get 5 values returned back to us, or size of returning the number 5. We can demonstrate that by just doing a /4 at the end, and we get 5. Which means that now we can index all the variables in the array int. This is really simple to do with a while loop. We can actually just make another integer, we'll call it c, equal to 0. Now we'll do something like while c is less than size of nums divided by 4. Actually, let's just get rid of int I. Then we want our while loop to perform printf and then %d \n, so each thing is on a new line, and we'll say nums index of c. Now if this works out fine, we shouldn't get any errors and it should list out 1, 2, 3, 4, and 5. However, I messed up in my logic and it just kept repeating 1. At the end here we need to say ++c semicolon. That way c is incremented. And there we go. We get 1, 2, 3, 4, and 5. So it worked fine. That's really a common thing that people new to arrays will use size of for. You can use it for a lot of other things once you get into pointers, but being able to use that allows you to just dynamically index everything inside of an array, which can be useful for a lot of programs and has many uses. Now, like I said in the beginning of the video, I'd want to go over the difference between single quotes and double quotes. So that's what I'm going to do. This is a really easy way to demonstrate this is with printf. Now we've used this function a few times in the past, and if you use any type of IDE, for me I'm using dev C++ 5.2, you'll probably get some sort of tooltip that pops up like this, and it says integer __ ODCL space printf parenthesis constant character pointer restrict format comma ... right parenthesis. Now where it says character pointer, character star, asterisk, whatever you want to call it, that is where this double parenthesis words double parenthesis go into order. Everything inside of here is treated as a pointer of characters, and then each character inside of there is treated as a single character from an array or from a pointer. When they do that, they actually take the value of A, the value of S, and so on. Now, C uses a single quote to derive the value of a character. So double quotes will treat it as a pointer which doesn't actually have the integer value. It just says that this is a pointer to these characters. So when you make an array of characters, you need to make sure that you use single quotes so that you don't have some weird error saying that you're passing a pointer. Now if we do parenthesis w parenthesis and compile this, we get an error down here which says excess elements instruct initializer. And that's because it's not seeing one character, it's seeing an array of characters, which is bigger than just a character because it takes up more memory. Something else you can kind of experiment with is, what if you just typed words like that in double quotes? Very simple, right? Well, if you can compile and run that, it would work fine. You won't get any errors. In fact, we can printf %s\n word, and we get words out of this. Now the reason for this is because these double quotes treat it as a pointer, and as we'll see in the next video, pointers and arrays are very closely related, and so when you pass it a pointer to something, it just treats it as an array when you're assigning it this way. It's a little bit more complicated than that, but that's pretty much the gist of it. And so with characters, you can do this. You can put them in double quotes without having to do the brackets and the commas and everything. This makes things a lot easier for big programs that are going to have predefined words. The biggest advantage to this is that it just saves time, and it kind of looks simpler to a person reading your code. You don't have to do it this way, but it might be easier for you when you're looking over your code just to be like, oh, okay, that's what it says. It says one word, instead of having to go through each character and trying to read it that way, which might be hard depending on if you're used to it or if you're not used to it. How you use that is up to you. I don't really prefer one over the other. Sometimes I'll use one method of doing it, sometimes I'll use another method of it. But if you're going to have other people read your code, I would probably use this way just because it's simpler to read and it'll make your code easier to understand. And again, this can only be done with the character array. Any other type of array, you can't really do that because all other arrays are either arrays of character arrays or arrays of numbers and things like that, which if in double quotes would be treated as a character and not an integer. However, one more thing I want to go over is that characters actually have a value in the single quotes which you can print out or assign to an integer. If we do int I is equal to capital A, we will get 65, and I'll prove this to you guys real fast. This is going to be the last thing of this tutorial, but it's something useful, so you guys might want to see it. So as you see here, we have 65, and that's kind of why it's important to use single quotes instead of double quotes if you're using the first way I showed you of initialization, because it passes the value and it reads it in printf as like a number. So it goes, okay, 65 being formatted as a character is a capital A. A 66 is a capital B, and so forth. And so then printf can handle it. And also, you're not trying to put a pointer inside of an array of characters, which would give you syntax errors. Anyways, thank you guys for watching. If you have any questions or comments, feel free to leave them in the comments section below. If you want to ask me a question or have something that you feel the need to PM me about, feel free to do that. Subscribe for future videos, and if you really want to help out, help more views, grow the community, click the share button and share this video with all your friends. Thanks for watching, and I'll see you next time.